Hello folks, I am Ayon. Today we would be discussing about PySpark, which gives us the flexibility to combine machine learning and big data. Both these domains have been trending so much, right? These domains have been trending usually whenever you open your LinkedIn feeds or whenever you open your social media accounts. If you are into these domains, you might see that people or the organizations out there, they are trying to fuse these things, or they are trying to see if both these domains can be fused together so that they can extract the values, the most of the values out of that domains. So this is a brief introduction about me. I am Ayon Roy, a final year student of Bachelor's of Technology in Computer Science Engineering from Delhi, India. Currently, I am a data science intern at Lulu International Exchange, Abu Dhabi. It's a world's leading financial service company, and I usually work with the data science things in the financial world. And I take pride in bringing the Kaggle Days meetup community in India for the first time. This community is more into like a data science, machine learning enthusiast, where we usually meet and discuss about those things in data science or machine learning. So this is how our today's talk, or this is how our today's entire session would look like. I have divided the entire session into 6 parts. In the first 3 parts are very basic, right? What is big data? What is machine learning? And why do we need to fuse big data with machine learning, right? Because this would give you the edge, or this would give you a better understanding about why is the need, or why you should listen more about this topic, or why you should even consider about learning these topics. Then once you know the basics, you know why should we fuse, then there comes the terminologies, there comes the concept of Apache Spark and how its architecture will help us in doing machine learning, data science related stuffs, right? And what usually happens is whenever you go into this domain of machine learning or data science, you would hear that people usually prefer Python, or they usually prefer R. So, but me being a Python lover, I would just try to brief you about how you can utilize the Python API with which you can explore, or with which you can do your things using the technologies, or using the advantages that Spark as a platform or as a ecosystem provides. And then Spark's machine learning library, which will help us to do machine learning seamlessly. We will see how machine learning library of Spark will help us to do machine learning, or help us to achieve doing those algorithms, achieve doing those regression classification type of things so easily with the help of PySpark. So without wasting any time, we would move ahead. Before proceeding, I would just request you to take a pen and paper, so that you can take notes about what I am discussing, or if you want to know more about these things, you can definitely ask me about those things at a later point of time over my social media handles or through email, which I will share at the end of the slides. So this is like a very big or like a very high level overview about what big data is. So big data, usually what happens is, big data, whenever we hear, it's more into that we have huge amount of data. Like the data can range from terabytes to petabytes, even more than that. So big data usually deals with those kind of data, or these kind of volumes. So if we define the big data, maybe like you might hear usually that big data is usually synonymous with 4 V's, like volume, variety, velocity, and veracity. Why usually we define big data with these 4 V's is because volume is big data, the huge volume, right? As we talked about, the petabytes or the terabytes of data that we have out there. So volume is huge. And the variety of data that we have, maybe it's a data from financial world, it's a data from IoT sensors, it's a data from, maybe like there are certain varieties of touch points from where the data could come, and you may store those data, or you may analyze those data. So here comes the variety concept, right? That you have variety of data out there. Then you have velocity, because let us consider the case of IoT sensors. What happens here is, like, the velocity in which the data is being ingested is very high, right? The IoT sensors usually send out data maybe in 5 seconds, maybe in 10 seconds, or even a minute. So that's a huge amount of data. And veracity is like, you do not know how the data sometimes behaves, or how the data is sometimes ingested. So there is an uncertainty kind of thing out there. So big data is like huge amount of data with majorly defined on the basis of these 4 V's: volume, variety, velocity, and veracity. So this is a high level overview about what big data is. And machine learning, like both these domains, big data and machine learning, are rocking the market, right? So in simple words, machine learning is an approach to achieve artificial intelligence. So artificial intelligence, maybe like you can think about this domain as where a machine could take decisions or machine could think like a human brain. I'm not speaking that AI would 100% overtake human psychology or human brains, but it's like we can get closer to that. And like artificial intelligence and machine learning is just a way, is just an approach to achieve artificial intelligence as a whole. And like subdomain of or subfield of AI which teaches the computer, right? Machine learning, you make the machine learn how to do certain stuffs, or how to learn. Like as a child we used to see multiple fruits pictures, multiple animals picture, then we used to say that this is a dog or this is a cow. Similarly in machine learning, you train your machine, you send the data to the machine that, hey, see, this is a cow, this is how a dog looks like, or this is how a cat looks like. Then the machine learns, right? How we as a child used to learn. So machine, we now train our model so that our machine could become more and more intelligent and can do the tasks, and like prediction or forecasting, something like that, right? So that machines can help us in a day-to-day activities. And like it's usually a mixture of mathematics, programming and these things, and with which the industry out there is usually usually implementing machine learning concepts and getting the benefits out of it. That's why, keeping in mind that machine learning, the scope of machine learning with which the organizations out there are using, and the big data, because why we need to fuse now. Up till now we just discussed what big data is or what machine learning is, but why do we need to fuse it? Like why should we fuse it, right? Because these domains are like big data deals with huge amount of data, and machine learning deals with learning from the data, so that our machine could do or machine could predict something at a later point of time. This is a graph, like, because usually what happens is through graphics we can understand better. So here it's a graph, like how the data creation or like how the data growth have been in the latest times. So this is how the growth of data have been. So if you see, 90% of the world's data was created in the last 2 years. Like let us consider the case of India as a country. So starting from the last like 3 to 4 years, the data penetration or the internet penetration have been huge in India. And like when the internet penetration is huge, people have been using services, and there comes the huge amount of data being ingested. So multiple companies now in India have huge amount of data. So like this is somehow the growth of data ingestion have been in the past few years. And you see like 2020, like the year in which we are. So like this graph is though a little bit old, but 2020 you can see like AI and deep learning. So that's where we are moving ahead, like machine learning. And that's why we need to fuse, like you see the data growth. And with this comes the concept of big data, because big data also deals with huge amount of data. When you have these huge amount of data out there, like the big data concept comes, and then what will you do? Like if you do not extract the values from the data, you are not getting, or you are not utilizing the best of the data, or like utilizing the best of what your data speaks. So you have to take care of all those things, and you have to combine, like that's the need. You have huge amount of data, here comes the concept of big data, and you have to extract the values from that data. So this is where machine learning and deep learning and AI kind of stuff come into picture. So now you understand why we need to fuse, like what will to in order to innovate, in order to add values to your organization, you have to innovate with different terminologies or different upcoming technologies. So fusion of big data and machine learning is something which industry is exploring, and I also think that this can be a huge advantage for the industry. And that's why I chose this topic, right? How we can combine. Then comes like Apache Spark. Like why I'm starting with Apache Spark, it's because if I directly go into machine learning things, or if I directly go into like machine learning algorithms, it would be like where is that big data thing going, right? So Spark is Apache Spark. If you like, you might have heard about Apache Foundation, they really do good works. So Apache Spark is a big data framework, or is a analytical engine, like computational engine if we say. So this is like unified analytics engine for large scale data processing. When it comes to large scale data processing, it means that you have huge amount of data. Like Apache Spark has been made in, or has been set in such a way that ingest or that can add values using the huge amount of data that you have, and you can utilize the concept of big data things. So you do not have to dig down into everything from scratch. So Apache Spark as a engine gives you that all that flexibility for large scale data pre-processing or data processing. And the best part is like Apache Spark definitely gives you those high level APIs in Java, Scala, Python, and R. So you definitely get that advantage, right? Because whenever it comes to machine learning, whenever it comes to data science, we usually prefer to use Python, we usually prefer to use R because of the libraries out there, or the community of these data science or machine learning people usually work with these two libraries. And like it definitely like now you see that there is an optimized engine, like Apache Spark is an optimized engine for which that supports the general execution graph. So what this means, we will definitely explore it in the future, in the further slides. So these are like the things mentioned in red. So these things are what Apache Spark is known for, or from where we can extract the values, or why we should use this platform, or why we should use this analytics engine Apache Spark. So Apache Spark gives you these things like Spark SQL. If you are into SQL and structured data processing, definitely you can use Spark SQL. Definitely gives you a huge advantage of using SQL and SQL queries. Then you have MLlib for machine learning, for like for all machine learning related things. You definitely have this library, and this is where our main agenda of the day revolves, right, for machine learning. Because like Spark have these concepts of Spark SQL for SQL and structured data processing. Then you have MLlib, that's our main agenda, machine learning. Then you have graphics for graph processing. Like certain kinds of organization do invest in these kind of techniques, or these kind of technologies where they play with those graph processing and like these things. And then you have structured streaming. Maybe you have heard about Kafka or like streaming services. So even with this unified engine, which is Apache Spark, you can do all those things. So our main focus today would be more into MLlib for machine learning. This is like how a Spark API looks like. Like if you just go on Google and search about Spark as a whole, so you might be like, you might get to see these three terminologies very often, like RDD, data frame, data set. So RDD is a resilient distributed data set, and data frame and data set. So here you see that there have been a huge innovation going on, there have been a huge thing going on, right? RDD was introduced in 2011. Then in the few further updates, data frame came in 2013. Then you have data set 2015. So like these are the few features of the APIs that you have. RDD, like distribute collection of JVM. So JVM is like Java virtual machine. So whenever you work with Apache Spark, you have to make sure that your machine also have this Java thing installed already. And then you have functional operators, mapping, filtering, you can do those things. And like in data frame, you get the flexibility of row objects, because day by day, like usually people prefer this row by row objects, or like this gives you the flexibility for more faster computation, and you can just use your own functions like UDFs, like expression based operations. And UDFs, it is the best, like it is the reason why like so much people are crazy about machine learning and big data as a whole, because they have been already familiar with those things. So like then you have fast and efficient internal representations. Then this is data set. So dataset have been the both, like have been the best of both the worlds. It's type safe and fast. So what I'm talking about, these characteristics, you can definitely look into those things like RDD, data frame, and dataset. So these are some of the features: immutable, fault tolerant, type safe, schema, execution optimization, and the API level, right? The API level for manipulating collections of things. So language support like Java, Scala, Python, R. So data frame is usually what happens is whenever you work with those machine learning and big data things with Python, like now with no Spark as an engine, the functionalities it produce and the different APIs that it has. So these are some of the features of those APIs which you can definitely look into it and can see why usually people prefer data frames for machine learning and big data. So API for manipulating distributed collection of data, you have those things out there. But this is what functionality Spark provides. And till now we have discussed about big data, machine learning, why we need to fuse both of these domains. Then we discuss Apache Spark, which gives you that analytics engine for huge scale or big data processing, right? But moving ahead, you have to understand the architecture of Spark, how the architecture of Spark looks like, which will in turn help us to do machine learning, right? Because understanding of the architecture definitely gives you the better understanding of why this thing works, or why this thing doesn't works, or why should we tune those things, or how should we tune those things for our needs. Maybe machine learning is our need. This is a architecture of how Spark looks like, or Spark's architecture looks like. So you may see that in the left hand side there have been 4 divisions. So like the bottom one is Hadoop, Yarn, standalones. These are clusters. So Amazon EC2, so those who are on Amazon AWS, or like say they may hear about EC2 or things like that. And you can also have a standalone cluster. When I speak about clusters, so clusters are definitely let's say set up in your local machine, and you just play with those things, or you do those big data processing things in your own computer. Then you have Hadoop, Yarn. These are some of the, or like on the basis, like these are some of the big data technologies on the basis of which Spark was evolved and made so much awesome. So you may definitely look into those things like Apache Mesos. Then you have, above all, like once you set up the cluster, once you have the setup of the ecosystem in your machine, or once you have the access to the ecosystem on whichever machine you're working, then comes the Spark core. So Spark core, here comes the data sources from which, or from where you would get the data. So some of the common data, say data like from where you can get the data are HDFS, so Hadoop distributed file system. Then you have Hive, then you have Cassandra. Even I recently worked with MongoDB, so even data from MongoDB could be ingested into Spark core. And once the data from those MongoDB, or like huge amount of data out there, you just ingest them. Then you have these data frames like streaming, MLlib, graphics, as we discussed, right? Graphics for graph processing, SQL for those SQL processing and structured queries. Our main focus would be into MLlib, machine learning, and streaming is for those Kafka streaming services. And at the top of those things, like now you have the setup ready in your machine, then you have the data ingested in your machine, then you have these libraries on through which you can just play with those data which is in the Spark core. Then maybe like you would require a flexibility to use a language which you're already familiar with. So in this case, Python. So that's why like Python plus Spark. So here comes the terminology PySpark. So these are the languages, and with the Python API, you can definitely move ahead and can do those big data processing. But we discuss about clusters, but how would a big data processing work, right? Big data processing is usually what happens, like you will get an idea from here. So driver is the main program which entirely drives the process of big data processing. So your entire data comes through driver, and a Spark context is made. Spark context gives you the like the plan or the context of through which your data should be processed, or through which you should process your data or things like that. Then it has a direct relation with a cluster manager. So cluster manager is like you have like the entire work is divided into 3 or 4 chunks. So these are called workers. So workers have executors. Executor is the main part where the actual processing takes place. Maybe like in machine learning, you have those concepts of clustering, you have those concepts of regression, you have those concepts of like different decision trees, things like that. So you just execute those things in the executor. And every worker, like when it comes to worker, so every worker has certain chunk of the big data that you have. Maybe let's say big data is 100 GB. So workers get that, like 3 workers are there, so every worker gets 33.3 GB, 33.3 GB. On every part of that data, the executor, the algorithms that you have are run, and then they directly contact, or they directly are in relation with the cluster manager, because this is where the entire thing or the entire worker functionings are like combined together, and they are sent to driver. So driver is like you send a program to like to for data science or machine learning thing. The cluster manager just manages all those things. It works, or it combines, or it introduces different algorithms in which the executors are running. Then as a whole, it gives back the result to driver, and you are able to see those things. So this is like user program. So user program here, it's like driver. Then you have Spark context, as we discussed, like driver has a Spark context. So what actually happens in Spark context is like the data is divided into RDDs, as we discussed, resilient distributed data sets. So it divides the data into multiple chunks and it makes a directed acyclic graphs, as we told, like, because this gives us the flexibility of faster processing. And directed acyclic graphs, this is a scheduler, so through which you can schedule all your jobs. And cluster manager then definitely throws all these scheduled jobs into those workers, right? In this, like, you can see three workers. Similarly, like driver, Spark context, cluster manager, like this is a driver where the user program is, then there is a Spark context which plays with those RDDs, directory cyclic graphs. Then there is cluster manager, and it manages all the work through executors, right? A worker has some executors, and there is the task. So task 1, 2, 3, 4, maybe there are multiple tasks. So in case you require more detailed definition of what all those things are, what a Spark context is, driver is, executor is, so you may definitely refer to these slides. I will tell the organizers to share these slides with you, so you can move ahead and focus on those things. But how to harness the power of Spark, right? We discussed about the flexibility that Spark provides us, and there is a concept of those directed acyclic graphs, the drivers, workers, and the entire data is divided into certain parts, right? The data is divided into certain chunks, and the data is divided into like multiple things out there. So like, but how should we actually do those things, right? We should actually know how the work looks like, or what should we what should be our way of utilizing the potential of Spark through Python. So this is where Python plus Spark comes into picture. Like you have Python API, you interact with the Spark unified analytical engine that it provides, the driver, like all those setup that it provides, right? You do not have to dig down and have to set up all those things, because Spark usually gives us the flexibility to do those things, and you can utilize all the power of Spark with the help of Python. So there comes the concept of, on the right hand side you can see there is a concept of PySpark. Like we discussed about this architecture a few minutes back, right? A few seconds back, maybe in the few like 2 3 slides back. So here we have seen that languages, our main focus is on languages. So here you see that there is a Python which I have circled. So this is where we will use Python, and we will interact with the machine learning library that we have. Like in the library section you see MLlib. So this is where our main focus lies into, like how we can combine those things. But now we discussed about Spark, we discussed about Spark's architecture, we discussed about the Python API that we have. Then we also, like this section do majorly focuses on PySpark, but how a PySpark's architecture looks. Because as we told, like for in order to interact or in order to work with Spark, you need to have like Java installed in your machine. You need to have like, because when the Spark thing was built, it was like Scala, Java, these things were usually very common and people used to code with those things, right? But now as the Python thing started growing into the market, and now you have to see about how things work, or like, because you are now utilizing the power of Python to extract the best out of the functionalities that Spark provide. So Apache Spark was written in Scala programming language, as we discussed, right? But that cannot be a solution, right? How can, now should we learn Scala again to do machine learning, or to utilize the power of Python, or to utilize the power of Spark? Should we go back and start learning Scala? That's not a good, or that's not a feasible idea. So like what we have is, like we have a API of Python which we can definitely use, and we can like utilize the Python API for you, like for extracting the like best out of what Spark provides us. So then you have PySpark, right? And it is because, like, whenever PySpark works, this is a library called Py4j. So this is a very important library which helps you to interact, or which helps the Python API to interact with the Spark architecture. And we discuss about Spark context. Then you have workers, right? So in the blue boxes, these blue boxes are the JVMs. So here it's a Java virtual machine running. And like we discussed about Spark context, what a Spark context does, and a driver. Then you have these workers, right? In the middle, there is a cluster manager, which discusses, or which interacts with all those clusters out there, like workers out there. So here it is, like in the local machine, in the local setup, it's like Spark context. They have a socket through which the interaction takes place. And here you have Py4j. This is a library which helps the Python API to interact with the functionalities of Spark. which helps us to interact with the functionalities of these all these or like all the big data things that Spark provides. And then you have local file system. You can definitely interact with those things. Maybe you can play with your file systems that are saved in the local machine. You can definitely utilize those things, right? Once all things are in like in that API which is wrapped through Py4j, then you can distribute all those works into different Spark workers. So as we discussed, like Spark workers have executors. In executor, you actually do those tasks, maybe a machine learning task, maybe a machine learning algorithm. So like there is a pipeline like the which definitely interacts. So you, let's say, had 4 tasks or had 3 tasks which are coded in Python, or with through which you just utilize the PySpark API, or with which you use the PySpark library out there, right? To be correct, it's a PySpark library. So you can just interact, or you can just divide those 3 tasks, and you can make that 3 task run in a single worker. Once all the work of those single workers are collected through a cluster manager, you send all those things to Py4j, like this Spark as a Spark context as a whole, and then you get the entire result. So right, these white things are our Python boxes, and like where the Python setup is there. You do not have to install Python in everywhere like that. That is where Spark comes into picture, right? Spark sets up the entire platform for you. You can just change the size of memory that you want to give, right? A Spark worker may be 8 GB, a Spark worker maybe 4 GB, as per your demands. So this is like blue ones are JVM, like if you must have a JVM installed, and the white ones are the Python, right? And definitely this is the most important thing, like Py4j library you should be there to work or to relate with those things. But how Spark's machine learning library will help us achieve goal, right? Because we discuss about the certain things that we have right here. MLlib, we discussed like MLlib is our main focus, that it will help us to do machine learning. It will help us to do those certain kind of things which we want to do. And then you have this Python wrapper out there. Then we discuss about the PySpark architecture as a whole, how the PySpark's architecture looks like as a whole, and how we can utilize the best thing, or how we can utilize the power of the unified engine that Sparks provides us. So this is like how Spark's machine learning library will help us, because we usually have already things out there, right? We have the code for linear regression, we have the code for data decision trees, things like that. But how we can utilize the PySpark library as a whole, PySpark library as a whole, which gives us the flexibility to use let's say the like linear regression, clustering, regression, like these machine learning terminologies, which you can definitely like utilize the PySpark library, and can see how you can utilize the functionalities in the library and can fuse both this machine learning and big data as a whole. So machine MLlib that we were talking about so like so commonly in the past few slides. So MLlibs give you that Spark's machine learning library, and Spark's machine learning library gives you these flexibility, like ML algorithms you have, then you have featureization concepts, then you have pipelines, then you have persistence, then you have utilities. So starting from utilities, so utilities gives you the flexibility to use the already built things in the PySpark library, which helps you to work with those linear algebra, statistics, data handling, or data like things like that. Then you have persistence, like saving and loading of algorithms, the machine learning algorithms that you make. And then in pipelines, right? Pipelines, if you have heard or if you have worked with machine learning, you might have heard about those scikit-learn pipelines. So you make a pipeline in which way the entire functionality would go, in which way the entire thing would go. Then you have featureization, the feature extraction, like feature engineering kind of things, right? We do feature reduction or the dimensionality reduction, then we do feature engineering, then we do EDA kind of things. You can definitely do those things. So this is where these are the functionalities which MLlib provides us, and this is where this is a huge advantage for us as a whole, or us as a like as a person who is trying to fuse data science, and who is trying to fuse big data and machine learning as a whole. Then you have machine learning algorithms. So you do not need to write import scikit-learn to do some classification, to do some regression. You can utilize these libraries, like the PySpark library already has these algorithms like already built, though you can tune, though you can tweak those features according to your needs, but you have definitely the opportunity to use the already built algorithms in that PySpark library. So this is how a Spark machine learning workflow looks like. It's similar to what we usually do in scikit-learn. So it is like we divide the entire data set into training data set and testing data set. Then we load the data transformers estimators, right? Transformers is like we transform the features. Let's say we do one hot encoding, we do label encoding, we do feature reduction, we do a lot of feature related things, right? So transformer gives into like, it transforms one column into other, so it's more into transformer kind of thing. Then you have estimators where the model, like where you play with those features and at the end come out with the entire, like come out with the entire solid machine learning thing out there. Then you make, then here is where you train the actual model and save the model, and then you can evaluate, like evaluate in the sense accuracy, R2, like R squared, or like AUC, area under curve, you can think, like do those things. And once the model is trained, you can just fit and transform, right? Like as we do actually do in scikit-learn, as we do usually in how a machine learning algorithm, or how we do end-to-end machine learning things, like how a machine learning pipeline looks like. So this is how a Spark machine learning workflow looks like. We ingest the data, we then extract the features, like do some feature engineering, and we make a transformer. Though there are multiple kind of transformers, maybe you can use a transformer inbuilt, or maybe you can make your own custom transformer with the help of Spark. So that, like I will share some resources, you can definitely go there and can check out. Then this is estimator, so where you train your model and you can utilize this model for testing purpose. You can just ship this model in the production. So this is how machine learning workflow looks like in Spark. So data frame is like we like ingest the data, or like maybe the data is stored in MongoDB or things like that. So ingest the data, and then like transformers is like you play with the features. Maybe your data set or data frame has some features, and you want to do one hot encoding, you want to do label encoding, so you can definitely do those things with transformer. And estimator is like where a learning algorithm, maybe a machine learning algorithm, where the linear regression, maybe clustering things work. So you can do those things in an estimator. And pipeline is like a combination, like once you transform multiple features, do some feature analysis, and at the end you use those features to make a model, or use those features, or apply your algorithms on those features to get a model at the end. And pipeline is the entire workflow. So you may consider this as an entire pipeline, how things work. So it's a combination of transformers, estimators, multiple, like you may do multiple transformations, multiple estimations. So you can definitely do, even you can read those definitions here. Like as we talked about pipeline, so loading the data, then you have different stages. So pipeline gives you the flexibility to define the stages. After this, that, after this, that, after this, that, you can definitely move ahead and can do all those things. Like then at the end you get a prediction. So like prediction is, which is your, like your model's output. So you can utilize those things in production, you can utilize those things in actual world, in real world. So like Spark's machine learning library, like if we talk about like what, like at the high level overview, what this library provides us, it's like these are the features, some of the applications which Spark's machine learning library provides to us. It's like collaborative filtering, like maybe like for a recommender, like let's say you want to make a recommendation engine on a huge data set, which is like let's say Amazon or YouTube. So they have huge amount of data out there, and they want to make their own recommendation system. So how would that work? So they have huge amount of data, but they also use, even Uber or like some ride hailing services like this also utilize the potential of big data and machine learning to predict the demand of cabs, to predict the demand of like to predict the fares, things like that. So you have the features out there. So you can do collaborative filtering for recommendations. Then you have logistic regression, like different kinds of regressions out there. Then you have the like linear analysis, k-mean clustering. Like even you can utilize the concept of Gaussian concepts. Then you have Bayesian concepts, which you can definitely do with the help of Spark machine learning. Then those naive Bayes and like ensemble methods, you can ensemble the models and things like that. And then you can do definitely, like these are the most important part of feature engineering, PCA and singular value decomposition. So even you want to do like data cleaning, data pre-processing, feature engineering, Spark's machine learning library gives you all the flexibility. And that's why it was important, that why machine learning and why should we fuse big data with it, or what's the Spark's architecture which will help us. And we gave a high level overview about the architecture of how Spark looks like and how PySpark's architecture looks like. So these are a few useful resources which you may look at a later point of time to learn, to explore more about these things. Definitely, like though it may sound a bit tough for you at the initial stages, but definitely like it's not that much tough. You can go step by step. You can just refer to these resources, which will be definitely a good pointer for you. And like, if you have any questions, do let me know. I will be very happy to answer them at my level best. And you can just let me know how you find this talk, or if you have any questions regarding the talk, or if you want any help with PySpark, or if you want any help with how to move ahead with those things, you can definitely email me at ionright2000@gmail.com. And you can send me, like you can add me as a connection on LinkedIn, and we can take the conversation ahead. Or you can visit my website ionright.ml, and I will tell the organizer to just upload this slide so that you can utilize this slides content at a later point of time. And feel free to reach out to me. So thank you for listening to me, and I hope that this talk was useful. And if you have any further questions, you can let me know, and stay safe. Bye bye.